people can feel free to join. It'll take a while before I do too much else in here. But another thing that I've popped in the Discord, I'll just move my head over for a second, is a channel for downloads. And this gives you the shortcut to download any of the files that I'm working on. So if you've been following along with this project or jumped in just for this stream or missed some of the models, you can follow these links to download the files. Now, the off-road buggy there is from my previous lessons where there's a whole recorded series available on YouTube on Fully Defined. The Volvo wheel loader at the bottom is the one we've been working on, and we're ready today to go through the assembly. So, for anyone that doesn't have SolidWorks 2023 or newer, or is using a different CAD software, you have the ability to download and import step files. So that's the first thing I'm going to go through today, to show you how that works. Just bear with me while I open a couple of folders. So what we'll have here, just going to make a temporary folder. Okay, so here's my temporary folder. And what I'm going to show you now is what to do when you download the files. So in our example of this loads, just give me a second. Looks like we're having some lag issues. All right, so if we go here and you follow the link will take you to a Google Drive. And in that Google Drive, you can see SolidWorks 2023 and STEP. Now your view might look slightly different to mine because I'm the owner. But let's say you're getting the STEP files. The one that I'm going to recommend you to download is the wheel loader step, which is the top file. Now that is an assembly, but let's see. I'm not sure if it's going to have all the detail in it that it needs. I know I've done this before with the other model, so let's just check that quickly. So on the Volvo wheel loader, we go into step files. Just trying to find the assembly. There it is. Okay, same thing, should work. Let's just test it. So Volvo wheel loader step. I'm going to download the whole folder. So go download. That's going to compress it to a nice little zip file. Once that is, so that's been zipped, now it's downloaded. Now I can open that and then open my folder. Before you import any files into SolidWorks, you must make sure they're unzipped. So I've got my step folder here. I'm going to grab all of those parts and copy them to my temporary folder. I've got a temporary folder. You could make this any sort of folder that you want to keep and use to house all of the parts that you're working on. And I'm just going to close what I've got open here. And I come back to this folder that we've just opened up. Now they're all step files, so there's no file difference, no difference between any of these files that is noticeable. But if we open the Volvo wheel loader step, so the one that is not a part like everything else, but it's actually the assembly, I'm going to click and drag that into SolidWorks. And that assembly is going to open up and read as an assembly file. So then I can go to Supercode templates here, open my assembly template, and that shows me the assembled version. Now, I believe there is a way that I can break this into models, into the solid bodies, into parts, but I might need to explore that a little bit further. I've done it before, but it's not something I do regularly. It may be to do with the way that I exported the step as well. We might come back to it. I think another thing that you can do with this folder is if you've done some of the streams but you've missed some of the parts, well, this is where you can click and drag to import those parts. Now, you get the geometry, but obviously you don't get the SolidWorks features. That's the one downside of this process. We'll spend some more time on this later if we get the chance. Okay, so let's get into the assembly. Now, I'm going to open up two files that I had ready. And if you do have SolidWorks, these files are available in the download folder. So SolidWorks 2023. Excuse me. There's a file here that's Volvo wheel loader assembly ready. And that's the version that has all the parts in it. Not this one, but this one over on the right. It had all the parts, but no mates, nothing assembled, but everything ready to go. So saved you a bit of time. That's the one we're going to go from. All right, so before we get into the assembly, let's just go through a couple of things that we're going to be aiming for today. We've got about 2 hours to try and get through as much as we can. I think we'll be able to get all the assembly done, and that's just a matter of how much extra stuff we can do. We're going to look at getting all the parts in here fully defined, excluding the mechanism. We may want to retain some movement in the mechanism. I would also like to work through the gear assembly. At the moment, I just have this rotating, but I don't have the gears actually functioning properly. That might take some extra work or be another stream down the track. We'll use mirror components for all the elements that are symmetrical. And we will do ideally some interference detection just to work through some of these problems. If there's any interference between parts, which there probably is, you can see some examples already. So we'll try and work through that too. So I'm going to close this file. And the other thing you'd find in that folder in the Dropbox is, sorry, not in Dropbox, Google Drive, the instructions. Here. So this PDF takes us through all the detail for putting this together. It's not overly complicated. If you've read Lego instructions before, you know there's usually not many notes. There's a couple of arrows, and you need to spot the difference from one step to another. Now I've got a version here where I've just blown it up a little bit, and we'll refer to this as we go through. So one thing that I didn't get right when I did my first run at this assembly was the orientation. I would very much like my part to have the front face being where the bucket is. And I started essentially building it in the wrong orientation the first time around. You see this green detail here, this actually needs to be facing towards the back. So I'm going to keep that in mind as I start this model. So the model's starting with that grey piece and then 3 blue ones. I'm going to keep the front plane hidden and the top plane hidden. We're going to use the right plane for reference for our mirror. Also, as I want to get the orientation right, one of the first things I'm going to do is set the isometric view. So I'll just spacebar to get my orientation. I'll go isometric and I'll go front. So I can see this is the front view that I want to finish with. This is the isometric view. Here's my first part. Let's get this in a position that's fully defined, and then we'll start building the next parts in a correct orientation so that the green one is pointing towards the back. So we have to flip it around. All right, so first part. Let's here, lift our arm. Now I'm just going to drag that to the top of the assembly as well. We're not going to be too specific about putting these in step by step or anything like that. We'll group some parts later, but I just want to get the first one at the top of the tree. So this first one, it's actually the top plane that is running through the middle of the part, and we're going to use that to mate with the right plane. Now later, we will change its location as far as height. Once we put the wheels on, we'll lift up the wheels so the wheels are sitting on the top plane. But to start, we'll start with this just matching front plane to top plane so that it's aligned. And then the last one is going to be the right plane and the front plane. All right. So that part with those 3 mates, you can see here, 1, 2, 3, that part's fully defined. Now, the bottom of my assembly says fully defined, my assembly file, but I don't think that's right. There's only 3 mates. That's a bit weird. I'm going to save this as, because I don't want to oversave the assembly ready file. I'm going to change this as work in progress. Okay, so that one's fully defined. Now we need to do those 3 blue parts. And so instead of being 2 and 1, we're going to have 1 and 2, so that the green one ends up facing the other direction. So those blue parts are here. Now we're going to use press the mate tool, select the face, select the face. This is going to be a concentric mate. Very straightforward. We're also going to hit lock rotation. That's going to save us from having to do another mate to, with planes to stop that from turning around. So it can still move in and out until we do the next mate, but it won't rotate. And the next mate I'll do is this face here to this face. And that's what puts it in the correct position. I'm going to press OK. Just have a look at our assembly. So we're going to have 1 on this end and 2 on the other end. Now I've got this part here, one of these parts already. Just going to move that to the top of the assembly. Let me. I don't know why it doesn't want to let me change its position in the feature tree. It's very strange. Just close and open again. Hello, Hetz. Thanks for joining. Hetz, what version of SolidWorks do you have? Because if you have a newer version, you can download the files and follow along with the assembly. I think I put... There is a Google Drive link that has all the files available. I can share that actually in the chat, I believe. 2025, yep. See if that works. All right, so I'm going to do the next part. I'm going to grab a duplicate of this one. So I'm going to just press Control on my keyboard and click and drag, and I get 2 copies just like that. And then I'm going to do the same thing that I did with the first one. So concentric mate, lock rotation. Let me know how you go with that, Het, if you're able to open and play around. The file that you should open is in the SolidWorks folder. Open the one that says assembly ready. Once you've downloaded your copy. Okay, so for these parts, I'm going to make these faces, and I can do a multi-mate. So a multi-mate lets me select this face here and select 2 other faces and get them all in line at the same time. Press OK, and that's done. All right, so that's my step 1. Okay, so step 2, we're getting one of those black L shapes, but we're going to remember we're reversing. So what we're doing on this is reversing from the instructions here because we want the finished product, the bucket, to be facing the front, our front plane. So we have to just flick reverse the instructions when we're looking at them here. So my next part, the black one, just putting it on the other end. So let's come across here. I've got the part, drag that across, and I'm going to set. So the L shape goes in the middle. I think this hole and this part align. I'm going to flip the direction, and then I'm going to select those 2 faces to keep them parallel. And then these are going to be coincident, basically in contact, because they are both 8 millimeters, I believe, 7.8. Or should there be a little gap? I think there should be a little gap. I think I may have did this wrong in my first assembly. So I'm going to put a gap in here of 0.2. Right. Well, you will check for interference and things later. So we've flipped that one around. We can see it's got that little grey part that goes in there as well. So we're going to put one of those in. That's here. And that is going into that bottom corner hole with the long end going in first. It is all solid modeling, not any sort of surfacing. That is correct. No surfacing at all in this project so far. There won't be any surfacing. We've finished making all the models, all the parts. So now we are just doing the assembly and then some refinements to those models. All right, there is that part is in. All right, next step, we get a longer grey one, another blue, a tan piece, and an orange piece. So we're getting another one of these greys. I'm just going to duplicate that. I'm going to get another one of the blue ones. I'm going to get one of these tan ones, and then this orange piece over here. All right, so the assembly, the grey one's going to match these holes. And it's going to match this face. So it has a little gap. The tan piece sits in the middle, like that. We'll just go back to make that lock rotation. Not that one, this one. And then we're going to select this face to get those combined. It also has a blue one on the end. So here, I'm going to flip that, lock rotation, and get that face matching that one. So we've got those three, and then the orange one on the outside. So this orange one, I'm going to select this face and this face to be coincident. Now we're going to do here a width mate. Because this orange piece, you can just have a look at it. It doesn't have any, it's got a round detail here. We might be able to use that actually to line it up. I'll show you the width mate anyway. The idea with the width mate is it helps you find a middle of two parts if you don't want to select a plane. So I can select this face, this face, this face, this face, and go and press mate. And it's going to automatically choose a width mate here, centered, to get those two parts aligned. The alternative, because it does have that cut in it, if I can just see up here, this one, I can align that hole with this one. It's going to be concentric. And then I can press this face and this face to make them parallel. That should work as well. We'll have to check later. It looks like maybe it sits a little bit low. And see here. So we might have to tweak it. We'll see if there's any interference. That is step 3 done. Now we're up to step 4. And remember, we're doing this backwards, so that green is going the other direction. So it's got a green L shape with 3 of those blue pieces in it. I'm going to grab, I think there's only one green throughout the whole assembly. We're just going to grab that one, 3 of the blues. We're going to rotate it around. So I like to rotate these sometimes freehand before I make them. It just makes things a bit easier when using the mate tool. I'm going to grab all these concentric mates, lock rotation. So we've got 2 in the end and 1 in the bottom. I'm going to get them in the right position. Multi-mate. Okay, and then if I look at how it joins, it's got the top one going through that black piece. So I'm going to line up these two. Just move it across. Also going to line up this hole. And then I'm going to get this part to be in the middle. So I'm going to grab the top plane of that part and the right plane of the assembly and hit mate. and that moves them together. So that'll be fully defined now, those parts at least. All right, we are step 4 done. Step 5, now we've got a little sub-assembly here. We're not going to make any sub-assemblies, at least I don't think we will. Yeah, we're just going to use all the mate tools available to us here. I'm going to grab a couple of these parts and a couple of the short grey ones. Now I'm getting duplicates of these just because I know I use more of those later. So you can see what we're doing here. Hello, Awosmi. Thank you. Yes, it's pretty cool. If you have SolidWorks, you can join in the fun by following the link in the chat or in the description below to get to Discord. At that link in the Google Drive, you can find SolidWorks files and step files if you're not using SolidWorks. You need to use SolidWorks 2023 and above. If you've got older version of SolidWorks, you can use the step files. There's a little bit more work, but it works. Okay, so let's do the next part. So we've got this sort of little sub-assembly to do. So I'm just going to line up a large and a small of the yellow pieces and then those axle pieces. Now the large one's on the outside. So there's a few ways we can do this kind of mate. I'm just going to do concentric. And then I'm going to do a coincident. Okay. Now these axle parts that we did, they're rounded on the outside. So I can select that round face and this round face. And they're going to find the right location, but then I have to align them. So I have to select this face and this face to get it to align the right way. And then finally the end face to get it fully in the right position. So there's one that goes through the bottom hole, one that goes through this upper hole. So similar thing, we want to get these faces aligned, and this one aligned as well. With that all done, I can then put it in position. So we are mirroring this backwards just because we want a certain facing for our front view later. This one goes above that end grey point. So I'm going to grab my mate tool. I'm going to get, it's the middle hole, this one and this blue one to mate. And then it should be that those two parts basically match the same width as this, and they'll be parallel. Okay, so they'll be lined up. And see how that's working out. All right, next step. Yeah. The curved panel. Okay. So here they see that little rotate symbol next to the number 6. They rotate it around. So now it will match the current orientation we've got. Although on the reverse side, that's fine. I'll grab that yellow panel. There's only one of those, so I'll just bring that over. And I'm going to use the rotate just to move it around quickly. And then I can see, like from this point of view here, that hole, and it's going to be this concentric. And then to make sure it's in the middle, I'm going to look at that part, find its right plane, and get that matched to the right plane of the assembly. Is it easier to make Lego assemblies in the brick or this Technic form? I don't know. It's a good question. there is another model that I've done before, which I may as well, I'll open it. I'm not sure if it's going to cause any issues, but this other one that I've done before does have more bricks and parts. A lot more bricks and a lot more parts. And they have their own complexity to them. All right, so this is the off-road buggy. And, you know, the more complex parts in this one were things like some of these moldings, which are nothing really like your standard Lego bricks. Yes, they have some connecting points to them, but it's completely different geometry to like a normal 2x2 plate. You know, this whole assembly started with, this project started with a plate like this, 2x2. That's very straightforward. I made it in a complex manner that had a lot of configurations to it, right? So you could do all these different sizes. That's a bit complex. But yeah, I don't know how to describe it. There's complexity all around, different ways. Hard thing is that they're tricky to measure. They're very small. So the smaller the part, like these tires, you know, the trickier they get. Let me close that. That file is, by the way, available as well from the same Google Drive. So let's keep going with this one. We also have to align this hole here, so that gets fully defined. All right, looking good. Now we check against our instructions. Yeah, thanks, Osme. Very, very fun. A good sort of, I think, a good way to learn. You know, it's difficult for people to find parts to hone their skills, to learn different CAD systems. Measuring large objects around the house isn't always easy, but Lego is quite accessible. And Discord is working. I can see someone has joined the server. Welcome, Ditzy. Hopefully you find what you need there, but if not, let me know. So that part, that's done. So we're up to step 7. So we're putting on another black piece at the back and another one of those joiners. So this is the point where we start to use the mirror component. So I'm not just going to add like another one of these components over here. I'm going to save time. I'm going to select the right plane. I'm going to press mirror component. And I'm just going to go through and pick the components that I'm going to mirror. It's very obviously these ones here, the pin that's underneath it, this grey one, this yellow one. We might not be up to all those steps, all right, but they're coming. So I'll just get a few of those in. I'm not going to do these 2 yellow ones yet. They will come later. I'm going to press next. We can see the preview as well. So the purple and yellow ones here are the ones that are getting mirrored. I don't need to do anything fancy with these settings for this example. I think everything works out. I'm going to press the tick. You can see there, we just saved a bunch of time. Now we'll come back and edit that mirror component later as we add more components to it. We don't need to do multiple mirrors. If we're using the same mirror plane, we can just edit that one over and over to put more parts into it. So that's step 7. Step 8, we've just done with the mirror, so we don't have to worry about that. Step 9, well, here we go. We're putting one of those yellow pieces on. And then it's getting more complex. So I'll put that one in the mirror. So I'm going to edit the mirror component. Just going to select that inside one, press OK, and you can see that's across there now. All right, I'm going to hide the right plane, don't need that anymore. And now we have a bit of a more complicated sub-assembly to put together. So we're starting to do these gear components. we're going to start with this. We're up to step 10. So to do this, one thing I'm going to do is I want to rotate this part, and I want to rotate it so that it is facing up. So I'm just going to grab these two faces, press mate, but in the mating tool here, over on the side, there's an option to just use for positioning only. If I press the tick, that means it's going to rotate the position of that part, but it's not going to add a mate to it. Right? So I've got it in the right spot now. I'm going to temporarily fix this part. And that means this one, you can see the little F next to it in the feature tree. This one can't move, but it makes it easier to do some mates to this part for other parts, like this grey one here. So I'm going to grab, I'm going to need a few of these. I'm going to grab a duplicate. I'm going to use the mate tool and get this concentric. I'm not going to make this one lock rotation because this is one that will spin later. And I'm going to use these faces to fully define that one. Well, sorry, to locate it. So you can see here, it can spin. All right, next step. Now we're going to put on 2 yellows on the outside and the worm gear. So the 2 small yellow pieces are over here. We get those 2 in, and then the worm gear. Bring that across. Okay. So I'm going to mate, and same thing. These are rounded crosses, so I can use a concentric mate, and then I can use a coincident or parallel mate to line up the faces. And in this case, these yellow small parts go all the way into that inner position. You don't have to do the mates in the same order. So this one I can do coincident first, concentric second, and then if it's rotating, I can do the last one parallel or coincident last. Now the worm gear is just like anything else. It's got a concentric face going through it. I can drop it right down to the bottom here. And then to get it to rotate correctly, I need to do a mate for these 2 faces. And then later, once we fix, let's say, this part, we'll find that this one will now rotate. Right now, this one's rotating. This one's fixed. Let me change it. So I can make this one fixed, this one float, and now this can rotate. Cool. Save. Keep going. Next step. All right, we've got this thing to build. So we've got another grey one in the middle. So this one here. I've got a two of the grey axles, 2 of the yellow round parts, 2 of the yellow longer parts. So I need to get 2 axles. Need to get one of these, 2 of these, and another 2 of these. I'm just holding the control key down when I click and drag. So how does it go together? We have this one on the outside. I'm going to temporarily fix this as well. I'm going to grab this face and this face for concentric. This one and this one coincident. I want to rotate this up. I'll get that face, and that's going to line it up. Cool. Alasme, I noticed you are mating the physical parts more than aligning the axis or planes. Why? It's easier. I'll use the planes when I'm trying to get something symmetrical, like in the middle of my assembly. I find it easier to select like a round face than it is to select an axis. Like I can view temporary axis here. You can see these very faint blue lines. But I prefer to use the face. You could do either. In most situations, either one will be perfectly fine. Good question. So next, I only needed one of these, so I can delete one. And this one, I'm going to mate, do the same thing I just did. Concentric, parallel or coincident. Then I get a couple of these yellow pieces in. Same thing, concentric, coincident. I'll do the same for this one. Concentric, coincident. I want to make sure that they're lined up properly. This last one will be a bit tricky, I think. It's rotating. But I can see that face in there is not quite straight, that one. There we go. All right, and then let's put this one on the other side. So, same thing. Okay, now we can see clearly here there's something wrong with our dimensions. We'll address that later. Now, where does that part sit? That drops on top. It's a bit blurry here, but I'm going to float this one, bring it over, mate this to this, and just bring it up high enough so that it's over the top. And then I think the gear sits on top of it after that. So grab one of these gears. Just use this one. I'm going to make those concentric. And then this gear is going to sit on this face. And then I'm just going to make sure inside that they are also lining up. All right. So we can see it turning. And I think now, no, we can't quite put it on yet. We've got to put this black one on. So it is becoming quite a bit of a little sub-assembly. So we get a black skinny one. And this is one part that I didn't have in the assembly earlier. So that's a bit of a mistake. It's okay. I've got it here. It says yellow. It says black, but it looks yellow. It is black. There we go. And this yellow one I think I need. Yeah. So I'm going to mate this one, mate this face. I'm going to rotate that down. I think the next one sits on this. Yeah. All right. Oh, is that too high? Yeah, that's the wrong hole. Selected the wrong hole to mate to. delete. Needs to be this one on this one, like that. And this is why I didn't make this before. This part here actually can move up and down ever so slightly. You'll see that in a minute. I'll actually change that, mate, once I've done this next step. So I don't want the edge, I want the face. And then I want to have this not rotate. Cool. And then it's got that black part going through the middle. It's over here. So I'm going to grab that. Like that concentric. It's coincident. That's one that can be lock rotation as well. Right, then it has another black piece on the other side and then one yellow one. So I'm going to grab another black. Now I can make concentric like this on the outside as well. That works. Coincident. And concentric. And yep, we can see some of the fitting issues. So it's probably a good time to deal with them right now before everything starts getting hidden into the assembly. We can see it's got the yellow outside piece there. I might just do that in the mirror in a minute. All right, so let's just have a look at what's not fitting on this. So first up, this black one. I'm going to save the assembly and I'm going to edit this one, and I can see the width of that is 15.8, which from experience I know that that's right. I'm happy with that. We can also now do a more accurate measurement because I have better calipers. So let me show you this. All right. And the parts in question. Right, so this one. Here. Now in our CAD, just going to isolate the part for a second. And I'm going to edit the part. And we can see we gave it a width of 4 millimeters. So from this face to this face, 4. What is it actually? So these calipers are much more accurate than what we'd used previously. Its actual width is 3.95. Not bad. Okay, so I'm going to change this to 3.95. Tiny bit smaller, everything else can stay the same. Exit isolate. And save. Let's check that grey part. This one as well. There's this one. To make sure I've got the width right here. So go here, measure 7.8, 7.85. If we have a look at the width of this, what are we getting? 7.8. Okay, that's close enough. All right. These yellow ones. See the width of these. 3.97, just under 4 millimeters. If they are 4 millimeters, they can stay as that. 3.9. That's interesting. 3.93. There's a bit of variation as you'd expect. If I put two of them side by side, 7.9. So probably 3.95. I'm measuring the physical pieces because this is how I modeled all of the pieces from measuring them one by one. So this whole project, everything that you can see here, I have modeled from scratch. These are not downloaded from some existing library. These are parts that I have modeled one by one. As you can see here. So all the dimensions are dimensions that I have taken. And when I did these parts, I had a crappy pair of calipers at the time, so they may not have been as accurate as I can see now. For instance, this 23.4 rather than 23.2. But I want to make sure that those holes, they should be 8mm apart. I might revert that. We want to make sure our assembly fits together too, so that's pretty important. What it can mean in this example, like if we look at this black piece here, this one is 15.85. I'd say it's 15.8. What did I model it as? 15.8. That's fine. All right, so perhaps I just need to add a bit of clearance in here. So this, let's say from like this face to this face, should be another 0.1 further. So I can look at the mate that's there, and I can say, okay, there might be a 0.1mm space, and there might be a 0.1mm space on this one. All right, once I've done that, these two as well, and say maybe they're going to sit on the outside faces. So they've got a little bit of clearance. And now this one fits. I don't have that interference like I did before. It does look bigger though, doesn't it? So see this black one's 3.6 radius. Got that part here. All right. So it's actually 3.7. All right, so if I open up that part and I have a look at how it's built, I can change that, 3.7. I can update the width, remembering that the hole spacing needs to be 40. Sorry, the hole spacing needs to be 8mm, so we're at 7.95. Can't have that. It's 8. And this black one, I have that as 7.8mm. That's correct. All right, so there's a little bit of difference in size. And that would be the next step of this project. Like, as you assemble things, you can see how they fit. So you can see where there's clearances or interferences and how accurate you are, and you can make adjustments to your model. That all looks good now. We'll do an interference detection later. Let's keep going and put more of it together. Yep, it was a lot of work. But for this project, to do all the parts you see here, only took us about 10 hours through 5 different streams. So it was pretty quick. Pleasure. See you next time. Okay. So we've got to put this on now. We can see it kind of flips around. Black pieces are facing the front. Now, is everything here? Is anything fully defined? Locked in? So is anything fixed? Yes, this one is. So I'm going to float that one, and I'm going to rotate it around like this. Now, some parts might, as we're moving the assembly, some parts might like get out of position, right? That's fine. We'll just bring them back in when we're ready. So how's this sit? We can see the top ones joined together. With, there's the gray one, this one. This one comes through the top, and it's going to match at that end. So I'm going to go mate. I'm going to hit this face and this face. Brings it almost in. And then this face and this face. And then a concentric mate. Parallel mate. That is now all in position. I'll just slide that one through. You can see this now, this will rotate as I move my cursor around in a circle. And there's no interference that I can see, so that's pretty good. All right, next steps. There's a yellow one on both sides, so I'm going to edit my mirror component, and I'm just going to click in that yellow one. So I've got one on both sides. And then that's everything on this first page. So we're up to page 2 of the instructions. All right, so we've got an L shape and a couple of pieces being attached to it. The L one is here. We also have a small one of those and a yellow one of those pieces like that. I'm going to mate those pieces first. So mate the concentric ones, lock rotation, do a coincident face, those two, and then for the axle, that's going to come through this hole. I'm going to line up those faces. It doesn't want to mate that one. Might have to play around with that. Let's just see where that piece goes. Yeah, it's going to put it in the right way. I think I did. That hole is going through there. So this piece is coming over here. I believe this is going to drop through the second bottom hole, and these faces will be coincident. Can then rotate that around, and I can see that this one, these two are going to line up, and this yellow one's going to go all the way through like that. So I can make that coincident. That's fully defined. Okay, cool. Now we're putting on just another one of those long pins on the back. So I think that one comes over here. So that's a concentric mate, mock rotation, and the outside face will match. Looking good. All right, now we've got this front subassembly to do. We are getting there. So this has another one of those grey parts. We have one of the blue ones. I actually have two of these gears, two of these axle pin connector hubs. I've then got this black one comes into it as well. All right, so I'm going to just want to rotate this one a little bit. That'll do. I'm just going to fix that temporarily. I'm going to put one of these through. And then these are going to be coincident. And then this is going to run through the middle of that. Now these two are going to be parallel. So I can use those faces to make them parallel. And then this black one fits on the end. Now it has a, I'll do a concentric mate. And I want to get it this face and this face going to be parallel. Something's happened there, it's not rotating properly. So I'm going to break other mates. And then whatever the broken mate is, there's nothing that's broken. I don't know why I didn't want to rotate there. If there was a broken mate, I could just delete it because I didn't need it. But this next one, I just make this and this coincident. All right. Now we're going to put that L-shaped one of these on the side. So the blue one sits in the third hole. So this one sits in the middle. Flip that direction. Get those two to be concentric. Doesn't want to do it. Does want to do it. Got to remove that parallel mate. Because those two should be, I should be able to make these concentric. All right, something's not quite right. I think it's that these two are coincident. I'm just going to delete that mate. That lets these two create a little gap there, and that lets this one be concentric with this, which is, that's fine. It's fine to do that. So that's all done. Then I'm going to put a long yellow one through the top with another one of these gears. So this is running through this position. Just want to make sure that they're lined up. And then that's going to have this gear around the middle of it. Again, get these faces parallel. And the gear is going to sit right in the middle. So I'm not made it to the right plane yet. What I'm going to do is use the front plane of that part. It's plane one of that part, and what will be the front plane of the gear to get them coincident. That way that gear stays in the middle. You can see it's got another one on the other side, which I'll use with the mirror tool in a minute. And then we can connect it. So I'm going to get the yellow one to go through that L shape. So I can now float the one that's fixed, bring this over here and mate this axle to this hole. And then this, I'm going to get the plane one to go in line with the right plane. Now I've just got to move some things over, but you can see most of the mates actually in the right spot. Right, this needs a coincident mate. All right, how's that looking now? I can do this, up and down. So we get movement. And to finish it off, I don't need to add in a lot of extra parts. I can just update my mirror component. I'm going to include this one and this one. You see that closes off those two sides. I do also need to include this little Technic pin here. And then this yellow one, so this will be coincident on the end face. All right, and that is looking really good now. We're on the home stretch. So we've been through all that step 12. Step 13, now we can connect the bucket. So that's this one here, the big one. How we're going to do this is there is a round face here on the bottom, and at the very center of this is another round face. So we're going to get them concentric. And then for this bucket, I'm just going to move it into the middle and find will be the right plane of each, mate them. And now that bucket is mated but can still rotate, which is fine for now. The last steps, we've got to mirror the other side, which we've already done, and then put on the wheels. So we don't need any more of these parts, I don't think. You can see our wheel is over here. We do need to mirror that pin. All right, and then our wheel, we're going to do two of these. So we're going to get first the wheel hub. Hey, Rock Laura, you're welcome, mate. I hope they work for you. Let me know how you go. I'm going to grab these two faces, make them concentric. Pull that across. I'm going to use this face to be coincident on the inside. And then with my tire, get that concentric. I can get the tire and the wheel to lock rotation. And then this face to the outside face. This way my tires can still rotate. Right. Now we're going to mirror that, but we'll have to do another one at the front as well. So I'm just going to put that in first. So concentric but locked. Coincident and coincident. Now, the wheels don't rotate at the same time. If we make them both, we choose like the top plane and the top plane of the other one. We got wheel top wheel top. We can make them parallel. And when they rotate, they'll rotate together. And now we can do a mirror component. I'm just going to grab all 4 of those. And there we go. Our assembly is done. We can save, front view, isometric view, just as we planned. So we're pretty happy with that. Yeah, now it's time to check for some interferences and fitting issues. I think, before we try and do anything with the gears. How'd you go? Anyone following along? Heck, I don't know if you're still there, but yeah, curious if anyone's got this open and had any chance to get through it. All right. Let's first, I'm just going to do a couple of other mates. Do a parallel mate for this one. I'm also going to, remember that very first part? We mated it to the top plane here. I'm going to delete that, because what we want to get is that top plane. See there? We want to get that as our ground. So these wheels are 23.6 in diameter. So if I move this part up half that dimension by getting the front plane and the top plane mate distance, 23.6 divided by 2, that should put it in the exact place that I want it. See that front plane now, or that top plane? It's running right where our wheels should be. Take time, Clara. I was asking more so for anyone that started assembling when I started today, but yeah, check it out sometime, those files in the Google Drive, see if they work for you. All right, before we do much interference detection, I want to clean up our assembly a little bit because we've got a lot of stuff going on here. A couple of ways I want to do that. I want to move all the mechanism stuff into a folder. Mechanism. And the wheels as well. There's only 4 wheels, but I thought maybe all the Technic pins could go into a folder. Basically, I'm just looking at ways to organize this a bit more, and I don't want to do it by steps. So I figure by just naming a few parts, that'll help us clean things out. Technic pins. Maybe lift arms would be a good one as well. What else for the mechanism? So all of this stuff, that needs to go in mechanism. Put mechanism at the top. Technic pins at the bottom. This one to the mech. This one to the mechanism. This gear. This gear. this one, this one. All right, so if I select that, and we have this one in there as well. That's most of it. Cool, Rockler. Thank you. All right, that's neat. Just put all the lift arms in a folder as well. Lift arm. So anything that says lift arm is going to go in there. This is completely optional. You don't have to do any of this. This is just me trying to neaten up the assembly. And now I've frozen. I find that I've got a new laptop and I feel like I get occasional random SolidWorks graphics issues. Like this example right now where it's just frozen on a drag of a part in an assembly. It's not great. So I'm very regularly saving. Of course, the computer's not frozen. It's just this. I can save, but can't quite get past that step. Rotate. Okay, good. We're out of it. That's a relief. All right, cool. So let's do some interference detection. We've got a little bit of time for that. So we go to evaluate, interference detection. I'm going to press calculate. And we're going to start with the big ones. So here I've got interference between this lift arm and this one. Okay. Now that's going to be because I've got this, I think, coincident when it shouldn't be. So this one here, no, it's not the mirrored one, it's this one. That face, got to delete that, mate. All right. So this one's mirrored. There's no interference on this side, but there is interference on this side. So this is where we play a bit of detective. And we're trying to work out what's going wrong. And you can kind of see it here that this one, it's like just in a little bit. See, some of these parts have different thicknesses, different widths. So they're not all lining up, they're not on the same plane. I'm going to suppress the mirror because that's just going to simplify some elements. Because this yellow one is 3.9, this black one's 3.9. This yellow one's 7.8. This one, these are not in the same position. Right, that's got a little bit of movement, right? So I just need to mate that one to this face. So I've got that little gap. Now if I unsuppress the mirror, still got that interference. But now it's consistent, it's on both sides. So what's the next step? Well, it's considering that maybe there should be a gap here. So you can see there's a gap here, but not here. So I want to look at the mates of this part. I can see them here. I need to edit this one. What I can do is even delete that mate and say, hey, that part, outside faces, should be in the same position. Just brings it out a little bit. Then if I look back on the top view, now I reckon that interference is gone. So we do interference detection, and that big one that was at the top will have disappeared. Then I can move on to the next one. The next one's between the gears. They're just in the wrong position right now, so I'm going to ignore that. And then another gear. And then this one, this is more important. That's interesting, between lift arm and an axle. So the axle that's going through it. I think it was these two. And what I can see here is one of my parts is misaligned. All right, so the hole spacing is incorrect. So let's just check the spacing of the holes. They should be 8 millimeters apart. That's correct. So somewhere here in this stack up of parts, there's an issue, right? So it could be this yellow one. If we check how it's built, can we do a measure check between? They're at 8s, so they're okay. It's not that. What else could have it in the wrong position? That one looks correct, or does it? Those two are off ever so slightly. One of them's at an angle. Very weird. I'm looking at this side view and see, like here, something's not quite right. This one, it can move. So I hadn't fully defined it, right? Well, that's an easy fix. Make those two, make them parallel. They should be coincident. It's going to highlight to me now what is wrong, which is good. Because if they can't be coincident, yeah, shows me something's gone wrong. So let's have a look at this part. This is between the holes, 8. That's fine. This one, 8. What else is joining these up? Is this part? Well, now we can have a look at our mates as well. We see what's red. This concentric one. So it might be the distance between these two holes. No. If I delete that mate, these can now move unintentionally. Something funny's going on with that, which we don't want. Let's hide that one. So those all look aligned. However, this part is currently underdefined. We could put this one, just get that centered. Okay. And have another look from the side view. So something's happening with that part, this part here, or these ones not being aligned. They're aligned now. That's okay. This yellow one, so it's the black one here. Top plane, parallel. It's very tricky. Just going to hide a few parts. So if these ones are all good, this one, what has this one made it to? That causes it to be wrong. Are these two misaligned? Doesn't look like it. Something wrong with this one though. Just going to delete that, mate. Just check those holes. They're okay. All right, it's concentric now. Let's show our parts again. Well, let's just do that interference detection again. Are we going for a crash? We could be. While we wait. Time to assemble. Can I remember it from the model? Maybe. One in one end. Right. Two. Need someone to poke the parts out. Okay. I think it's crashed, unfortunately. But I haven't lost much. Just some assembly features. Get it back up in a second. There. This one's supposed to have 2 of those. I think I missed this in the model as well. So those 2 grey ones. So that's stays on correctly. All right, so how do we deal with the crash? This is what we do. Close, restart. Now I can do this because when I'm just in the assembly, I'm really just dealing with any changes to the assembly, not parts, right? So it's rare. It's going to be like a major problem at this point. Now, meanwhile, my model. Get these together. It's neat. So get SolidWorks back. All right, so we can get back. Let's just save it at the top. Get back into our interference detection and see where we were at, which was ignore the gear, ignore that gear, and then we had this interference here between the lift arm and the axle. That's where we're stuck. Was that axle, that lift arm? I believe that's where the interference was. Yep. There's something going on with those 3. That the alignment of this. This one's not straight. Something funny going on with that yellow one. This one here. Yep. So we fixed that by moving this one to the middle. And is this one straight yet? Front plane here, no. Something's wrong with this. How could it be? There's a tangent mate there. That's what I don't want. That was the issue. There was an accidental tangent mate that I hadn't seen. So just looking through all my mates here, can't see any other tangents. That should fix it now if I can make those parallel. Unsuppress the mirror component. More mate issues. Doesn't like this one. Why not? I'll delete it, but I might come back and add that back in. Let's do that interference detection again. Should have saved it first. Yeah. So it's ignore that one again. This one's back. I have to fix that. Okay. Save. So these two faces. Parallel, no gap. What I want is these two to be parallel. No gap. It's tricky. Trying to do it fast. Get all these gaps perfect. See, this is interesting. It's got a radius of 3.7, 3.6. I'm sure they should be the same. .7, they should be. It's just then we have to get the holes in the right spot. 3.7. And 3.4. Yeah. Okay, it's better. That one should also be 3.7. That's okay. It all looks okay. As soon as we put the mirror back on, you can see these parts are just sitting, inside more than they should. So is this coincident? No, this one. Let's just give this a little bit of space. Nothing wrong with just adding a little bit of clearance in between your parts in this kind of example. All right, now we're getting down to smaller interferences. This one is okay. That one is okay. These are all the gears, teeth. So all these 21s, not this one, wherever this one is. That's different. That's showing me the length of something's a bit wrong. It's a good one. Okay, so let's try and address that. So I'm going to isolate all the parts it's related to, those three. I'm going to do a section view here. And I'm going to just make an assessment about what's going on. And I think we can see obviously here, this one should actually sit a bit closer, shouldn't it? Now that's the mirrored version. So I'm looking at the wrong side. I'm going to have to come over to this side. These two pieces. Do a section view here. And look at this mate. Change this mate from this face to this face. Now that's a bit tighter than I would like. There should be some clearance there, but at least now this fits all the way through. That's all right. It's going to be the same on this side, probably. So we're going to section. Going to update the mates for this one. get off that face and get onto that face. It's good. Why don't I just increase that clearance when we get a chance? Just like that. Cool, that should be another interference removed. Okay, where are we at now? We're getting some interference there. Now that's on the friction pin. That's okay. It says without friction ridges. That little bump, I think that's all right. Let's have a look at it. Some of the design of these parts. And you can see, so this is where there's potential that my measurements are off. High potential, because these are such small measurements and I can't accurately measure like the position of this gap. You would expect, looking at the design of these parts, that this thing should sit in the middle. So perhaps the length of this is wrong. Now I can measure that. Got one of the parts right here. If we go to this, not even this one, the full length of the part is 23.65. If I measure here, I get 23.6. That's close enough. Exit isolate and we have a look. There's a bit of clearance on both ends. Maybe it's just the positioning ever so slightly. This could be further out. But it's pretty small. I'm happy to leave that as is. Okay, so I think we're pretty good on interferences now. We're pretty good on the assembly. You can see everything here is fully defined, apart from this axle, wherever this axle is. This one. I know it's just a position thing, so let's get that mated. Okay. There's a couple of things that aren't fully defined. An axle here, which is part of the mechanism. The tires and the wheels, that's fine, we know about that. Okay, so everything on the outside, including the tires, is fully defined, the Technic pins fully defined, except for this one, because it's in the arm. Lift arm part's fully defined, so now it's the mechanism. And I think for this last section, we'll give it a go and see how we can go about trying to get these gears to function. Now, I see it as a big challenge. It's not something that I regularly have to do. Because we want to convert like a rotational gear from one to another. Look for a abrupt ending to the stream if I can't get it working. So these two. Hold on. I do not want to lock them. Doesn't like it. Rack and pinion. We're going to look at SolidWorks help. For the rack pinion mate, which is a mate I've never ever used. It's always a good time to learn. Rack pinion. Because it's not quite a rack and pinion, is it? No. Yeah, I don't know if we can pull this one off. I think it's going to take a lot more investigation than I can be bothered doing tonight. I know that this gear isn't perfect either, the way it was modeled. I'd rather just fudge the whole thing with a exploded view, a motion study, up and down. But why don't we finish off with an exploded view? I think that's the last thing that we can do. That's always pretty cool to see everything come together neatly. So let's do that. First, we'll just set an angle that we like. Probably going to be isometric. And I'm just going to give a view a name. And then I'm going to go to exploded view, and we're going to start from here. Now, I've done some of this before, where if I want to explode, let's say 2 tires, I can do that because they're symmetrical. But if I go into that one and I select like 4 like this, that's not going to work. All right, you have to pick this parts that are mirror of each other for it to work. I could do these as well. Then I don't get as cool an effect. So I'd rather do tires and then wheels. Wheels. And pins. One thing I've learned is you should probably try and explode even bigger than what you think, because then they can really be out of picture when you're doing some sort of like video capture, animation capture. Last thing you want is to see them before they need to be seen. Okay. So I've got all those done. Let's just do then front, straight off, boom. And then I think it's the sides. So back to one of these. We're going to pull these out. Okay, with that one off, I can then go get all of this in one go. I'm going to slide it along this direction. Just come out a little bit. And then I'm going to pop this one open. So grab these two. It's actually just that one done. And then I might, this one can come down. These two slide out that way. That one can come down. And these two can go out of picture. All right. Then we've got a few more parts that we can split on both sides. So we've got these orange ones. Out. These Technic pins. These tall yellow ones on the outsides. Remember, we don't need to follow the instructions perfectly, so all this is perfectly fine to do a little bit differently. Black ones. Yellows. Split these two little bushes off. And then we can take, let's say, these ones all jump out this side. This gear can come off, up, just like that. This one. This one. Nothing's holding that bottom one in there anymore, so I should have flicked that out already. It's all right. Just do yellow bushes again. Let's move these two, this one up. And then these two up as well. I'm going to have to leave that one actually. So now I can, like, to work out where this one should go, I can roll back in the feature tree, like this. I'll roll back a bit more. You'll see once these black ones disappear, that's when I should take that part out. So then I can do a step here and say, yep, get out of there. Okay. All right, a couple more to go. Let's get rid of these yellow ones. They can go out. Now we have this popping out. This one going out the front. Then all these blue ones, they're all going to go together. They're all the same length. I'm going to come to this near side. Going to have a split of these two pieces. I'm going to move this one out. And then we're just about done. Those two out. These two out. This one out. And this one. All right, that's our exploded view. Very quick. Now, let's have a look at how it plays back. If we zoom in, save, I'm going to do animate collapse. Not bad. Not bad. So you can tidy up a little bit. When you get to this point, you can do like a motion study and add like a camera to rotate around it while it records that. And you get some pretty cool effects. But I think that's a really cool way to finish. So, Rock Laura, thanks. Glad you liked it. Yeah, thanks everyone that jumped on for the stream. I'll now sit back and record a bunch of these videos to put out a few lessons onto YouTube in bite-sized chunks. But happy to take some feedback from this sort of process. Anyone that jumped on for any of the 6 episodes and has got to this point, if you want to see more, let me know in the comments or jump in the Discord or otherwise. So, yeah, cheers everyone and have a great weekend. See ya.